A very good morning to our lecturer and our fellow friends. I am Sugakesshaa with my friends Yogandas and Vinosan are going to present our mini project. Question 1. List and linked list. A linked list is a linear data structure where each element is a separate object. Figure A is an example of the types of linked list. Here we can see the figure A. The head is 10, is connected to 20 and 30 and 40, which is null. By referring to the YouTube, use figure A to explain about insertion and deletion operations of linked list. Please state the link of YouTube. First of all, insertion. I have chosen the inserting an element in a certain position of a linked list. The first node will always point to the second node. The link point of the first node points to the link point of the second node. When inserting a new node between a list, in between a certain point of the linked list, first of all, we need to update the link part of the new node. And then we can update the link part of the node before it so that we can still have the access to the next address. Here is the YouTube link for the inserting an element in a certain version of the linked list. Next is deletion. Deleting an element at a particular position of a linked list. When deleting a node at a particular position, first we need to take point of the address of the node before it. This is because we need to replace the address of previous link with the address of the deleted link so that it points out the next node and the address doesn't get lost. Hence, it's basically previous link equals to current link. Here is the YouTube video for the deletion. Question 2, stack. Suppose you have a stack with 5 elements which are C, O, V, I, and D are pushed in a stack, one after other starting from C. The stack is popped 3 times and each element is inserted in a queue. Then 2 elements are deleted from the queue and pushed back on the stack. Now one item is popped from the stack. Trace the popped item with the complete diagram. First of all, we need to create a stack with 5 columns. Then we push C, O, V, I, and D. And then, as the question, the stack is popped 3 times. So we need to pop the stack 3 times. Just pop D first, and then I is popped, then V is popped. So the stack is left with C and O. And then each elements which are popped are inserted in a queue. So at the right hand side, we can see the queue. First of all, we enqueue D, and then we enqueue I, which is the second one which is popped from the stack, and then V. And then 2 elements are deleted from the queue. So we dequeue the queue 2 times, which first D is dequeued and then I. And then the elements which are deleted are pushed back on the stack. Now we come back to the stack. First we dequeue D, so we add D, we push D on the stack, and then we push I. Now our stack are left with C, O, D, I. And then now one item is popped from the stack. So we pop the stack and the last pop item which is traced is I. That's all from me. Thank you. Next, my friend Yogandas will continue the presentation.
Thanks to Sugakesshaa. A very good morning to our lecturer and also to my fellow friends. I'm Yogandas Aridas and my metric number is 10DDT21F1112. So now I'm gonna continue our presentation with question number 3. Question number 3 is about Q, which is chapter 4 in data structure subject. Before we look at the question, I want to explain about Q. So what is Q? Q is an abstract data structure, somewhat similar to stacks. Unlike stacks, a queue is open at both of its ends. One end is always used to insert data called NQ, and the other is to remove data called DQ. Queue follows first in, first out methodology. For example, the data item stored first will be accessed first. A real-world example of queue can be a one-way road where the vehicle enters first, exits first. Okay, now let's jump to the question. The question is, assume that there are a queue of character P that has size 3. Show the output queue after the following operation are executed. So for this question, we used the cellular array. First of all, we have the create a cellular array with size of 3. Second step, we enqueue the A character. Here enqueue means insert, so we insert the data A into the cellular array. Third step, we have to enqueue the 5 times 3 equation into the cellular array. But here we have to insert the answer of the math equation. So the answer is 15. Fourth step, we have to dequeue. As I said before, dequeue means delete. So we have to delete the first data in the array. The first data is A, so we delete it. For final step, we have to enqueue the math equation, which is 10 minus 5. So we insert the answer of the question 5 into the array. And that's all for question 3. So the next question is for about tree. So what is tree? A tree is a non-linear hierarchical data structure that consists of nodes connected by edges. But in hierarchical data structure such as tree, there are multiple ways to traverse the data, which is pre-order traversal, in-order traversal, and also post-order traversal. Okay, now we jump into the question. The question is, use the tree traversal figure 2 to write the pre-order and in-order traversal for the following expression 3 in figure C. First of all, we have to find the pre-order traversal. So how to find it? The process of pre-order traversal is first we see the root node, then we see the left subtree, at last we see the right subtree. So the pre-order answer will be 1, 2, 4, 5, 7, 3, 6, 8. Now we have to find the in-order traversal. The steps for in-order traversal is first visit all the nodes in the left subtree, then visit the root node at last visit all the nodes in the right subtree. So the final answer will be 4, 2, 7, 5, 1, 8, 6, 3. So finally, that's all from me for today, and I hope my explanation was clear and helpful to you all. Now let me invite my teammate Vinosan to continue our presentation. Thank you.
Um, Thanks to Yogandas and Sugakesshaa for your wonderful explanation. So I'm Vinosan Karthikesen and my matrix number is 10DTT21F1114. So for my part, I'm going to explain you about question 5, which is sorting. Okay. To help students differentiate between the types of simple question, I often use a sorting activity. This activity well on my promotion active panel where student can drag the pictures to the appropriate column. I also send home the hard copy for practice using verbal responses or to use this activity as in figure. So you can see this is the figure. Next slide, please. Okay, here we calibrate 4 factors that should be reviewed before choosing sorting algorithm that is suitable to use this scenario. The first one is time complexity. Time complexity is the main factor to classify sorting algorithms. Complexity is defined as the number of times a particular instruction set is executed rather than the total time taken. The time complexity that needed is best time complexity. The second one is stability. A sorting algorithm is deemed stable whenever two objects with equal sorting keys appear in the same order in the sorted output as they were in the original input. Third one is simplicity. In the technology industry, considering the large amount of data, simplicity of implementation usually has nothing to say when it comes to factors like performance and speed. Algorithms like the bubble, quadratic, average, and worst case time complexity algorithms, they are not very popular in the computer world. However, due to their simplicity, they are used for educational purposes, small size data, and real life scenarios. The last one is memory consumption. Space complexity how much memory is being used regarding the size of input data. Some basic algorithms like insertion or bubble sort require no additional memory and can sort the data in place. On the other hand, more efficient algorithms like quicksort and merge sort and time complexity respectively, meaning that extra space is required to complete the sorting. So that's all from us. Thanks for listening to us.